Okay, in this video, we're picking up where we left off with our client and server programs communicating over a socket. Now, um, this is pretty cool. Enables communication over, basically any modern network. So you could have program, uh, you know, from running on one computer in your house, communicating to another computer in your house, to running it on a server in Russia and communicating to it from your computer at home. So um, this is really kind of breaking us into the realm of internet communication, but this isn't going to get us too far by itself because as designed, the server program can really only interface with one client at a time. And uh, to have any kind of server application that is providing kind of a large scale reusable service like a web page or an online game or something like that, you need to be able to serve a lot of users basically at the same time. And as you may recall from the previous chapter, this is where multi-threading comes in. Um, so basically all we need to do here, we're just going to take a lot of the same code that we have and we're going to make it runnable. Okay, so we're going to, and this is all on the server side, we're going to take basically all this protocol code here and we're going to stick it inside of a runnable object. And then each time our server receives a new connection, we just pass that socket to the runnable object and we start it and we let it go. And then that way, if another connection comes in, we're not waiting for that thread to complete. We can build a new runnable object, start another thread, let it go. And that allows us to basically have one thread running for each connection, each echo session that's going on. So we do need to introduce a runnable object here, a task, if you will. We'll just call it echo task. And that's runnable. So of course we need our run method. And our echo task object is going to need access to the socket that it's expected to communicate over. So we're going to pass that in through a constructor. All right. So we're assigning our socket through the constructor at the time we build the runnable object. So each echo task that we create is going to be assigned to one socket. All right. So now we can take pretty much everything from this point on down. Here's where we receive the socket object. So pretty much everything from this point on down, all the way down to closing the socket. This is the back and forth with an individual client. And so this is the thing that we want to operate in parallel. All right, so I'm going to yank this whole chunk of code and move it right over to our task. Okay, it's going to confirm some imports. That should all be fine. The only other thing that this is missing now is a try-catch block. We'll put a try at the top, catch at the bottom, and for IO exception. Backtrace, and then Alt-Shift-F to format. Okay, so essentially all I did was I took the exact same code that we had running in the server, and I delegated it to a task. So now every time we need to do this, we just take the socket object, pass it off to a new runnable, and we're off and ready to go. Now, back here on the server side, this allows us to kick this process into a loop, all right? And while true is not great, but it is a simple way to get a loop that's going to allow us to receive any number of connections. All right, so by putting this in a while true loop, we're basically saying, well, however many connections we can accept, that's fine. What we don't want to do is create a bunch of individual thread objects as so. We could do that. It's not horrible on a small scale. But what we probably want to do here is actually make use of the executor service. You may remember from the previous chapter. And we actually want to put a cap as to how many, simultaneous connections we can handle. So let's say, I don't know, 10. Again, it's not a huge concern. We could just create an individual thread object each time we run through that loop. The problem is, we get something like, 15 threads or whatever this computer can handle performance-wise, and then we start seeing some real problems. The executor service is still going to run our runnable object for us, but it's going to make sure that even if we get 100 connections, we're only going to be running 10 of them at a given time. The other folks will just have to wait. And that doesn't sound great if we're running like an actual online service, but it is a reality with limited resources. Alternatively, if you didn't want to put a limit, you should still at least use the cached thread pool. The cached thread pool is basically going to allow us to be a little bit more efficient by recycling our threads. So after someone's session closes, that thread goes back into a pool of threads that's available for the executor service to use. Either one is fine for our purposes now. So then when we want to actually execute the task, we could just do ex.execute new echo task. And of course, the echo task constructor requires our socket object, right? So what this ends up looking like is we enter this loop, our server receives a connection, passes that connection to an echo task object, and then we execute that echo task object. And then once that execution kicks off, the loop repeats, and our server socket is now available to wait for the next connection with no waiting. So just by making this one little switch here to dump all of this task code into a runnable object, we're going to see our server application actually handling multiple clients at the same time, just echoing their messages. So they won't see each other's messages, nothing like that. But let's just take a look. We'll run the server app now. Okay. Server is running and awaiting connections, and I'll start one client app. And this will be Zach. See that Zach has connected to the server. And then let me start another client app. And this will be Amanda. Right? And going back to the server, we can see, oops, didn't mean to do that. We can see both Zach and Amanda have connected to the server. And so Zach can type echo messages. Zach says hello, and Amanda can type echo messages. Amanda says hi. But again, they don't see each other's messages. But they are both connected to the server at the same time, and if I wanted to, I could start up another one. Right. All three people connected to the server all at once. Now I did put a while true in the server, which means that the server is not going to stop of its own accord. We didn't input, or we didn't leave any outs here, right? This is just going to keep going for forever, so I'm just going to have to terminate that manually. Not ideal, but for this simple demonstration, it's fine. What might be an interesting exercise to do is to transform our echo server, where everyone is just getting their own messages back, into a chat room server where everyone is seeing everyone's messages. That's essentially the basis for an online chat room. Now, this is going to get a little complicated, and it kind of goes outside the scope of what's required for the project. But if you're interested in seeing what you can do with servers and multi-threading and kind of a more complex configuration, then proceed. So essentially what we're going to need to do here is we're going to need the capability for each of these server tasks to communicate to all of the sockets, right? So each server task is still going to be connected to, it's still going to be servicing the messages from an individual user, from an individual client. But when it receives a message from one client, it's going to send that message back, what we might call broadcast that message to all of the clients, right? So if Zach typed in hello, then Amanda and James would also see Zach says hello, right? Even though they aren't Zach. So I'm just going to create a brand new task for this rather than complicate the existing one. And let's call it broadcast. Okay. This is obviously also runnable. Okay. All right, now we do know that much like the other one, this will have a socket that it's linked to, that it's in charge of serving. I'm going to call that my socket for reasons that will become evident in just a moment. Oh, yeah, import that. And all right, so we haven't made it final yet. Now, it's also going to need to be able to communicate to all of the sockets. So we're also going to need basically to create a collection of all sockets, or what we will call, well, let's just call it all sockets. Okay. And both of those, sorry, I can't seem to type public. Both of those are going to come in through the constructor for the broadcast task. Both the socket that this task is responsible for serving, as well as the collection of all sockets, so that it can broadcast. All right. Now we're going to need a little helper method here, private method. So that we can transmit, this is just to save us some space and time, so that we can transmit our output messages to all of the sockets. And this is just going to kick us into a for loop here. So for each socket in all sockets, we need a data output stream. Sorry. Before we get into that, all right, first of all, we need to check to make sure as we're going through each socket in this collection that the socket is still open. If you try to send a message to a socket that's already closed, then, well, it's going to fail. We're going to get some error messages. It's going to look ugly. So the first thing that we want to do is if not is closed. Output stream. Yes. So for each socket in all sockets, we're going to check to see if it's closed. If it is not closed, we are going to open a data output stream around its output stream. This can throw an I/O exception, but because this is a helper method, I'm just going to add a throws here. All right, so when we actually call this method, we'll have to do a try catch. But for now, we're just going to pass that exception of the food chain. All right, so we open the data output stream, and then we just write UTF, whatever the output is. All right, so this is going to accomplish the process of when there is something to send back, we're going to send it back to all sockets, not just my socket. All of the clients are going to see whatever message we write. Now, for the run part, I am just going to copy the existing code from the echo task, and we're just going to have to make a couple of quick modifications. So I grabbed all the existing code from echo task. Sock is now called mySocket. And we no longer need a data output stream for that particular socket. All of the messages that we send are going to go to everybody. All right, so for example, right here, when we are sending the message, you have successfully connected to the server, let's just replace that with broadcast message. And instead of you, we will say name has successfully connected to the server. Okay, so that way everyone will see every time someone connects to the server. All right, same deal right here. We can replace this use of the single data output stream with our broadcast message. And this is what's going to accomplish echoing that message to all of the sockets, broadcast. Okay. And then finally down here, these should also be mySocket. MySocket. It's only responsible for closing that individual socket. All right. Now, there is one more issue with this, okay? But let me run this real quick. Oh, sure. So we have to set up our collection of sockets as well. Let's just use, well, we don't care about them being ordered, and we know that they are unique, so we'll just use something like a hash set to hold our sockets. Don't need a list or anything like that. All right, so now, each time one of these things connects, we'll just add it to all sockets. Then we change echo task to broadcast task. And we add again to all sockets. Okay. Now instead of just doing a regular echo, we're doing a broadcast for each socket that connects. And so we will make sure that each task we create gets the collection of all sockets that have created. And of course, this collection will get updated every time someone gets added as well. So it'll be kept up to date. And let's give it a shot. Now we are going to see some issues here, but they're expected. That's right, you got to run this thing directly on the server first. Always have to do the server first. And then we'll run a client. And this will be Zach. Zach is successfully connected. And so we'll run another one. And this will be Amanda. Amanda is successfully connected. Now, what I would hope to see is if I come back here and check on Zach, that Zach would also see that Amanda is successfully connected. I do not, all right, which is a little troubling. But I'm just going to type a message from Zach and see what happens. I'll type hello. Oh, well, now we see that Amanda has successfully connected, which is good. But it's not what we expected. What we expected to see was Zach says hello. And in fact, well, we come back to Amanda and we don't even see that there. Send something back from Amanda. Well, now we see it. Okay, and so we're going to see a problem emerging here. I'm going to stop these. Because I forced them to stop, it's going to cause some issues on the server side as well. Essentially what's going on here is we made our server multi-threaded so that it can handle a lot of back and forth. However, our client was not prepared for that change. Our client was only prepared to accept a message. This right here, looking at our client code. Our client only reads a string from the data input stream every time it sends a string to the data input stream. So our client is expecting one message out, one message in. And that's not the case here, all right? Our client should very well be receiving a chat message even if it sends no messages. If someone else connected to the server sends a message, the client should be able to receive that. But the way our client is configured right now, that's simply not going to happen. The client will only ever receive a message after it sends one. Well, how can we fix this? It turns out the solution to the client problem is also multi-threading. We need to have a thread, the main thread, waiting for the client's input to send to the server. But we also need a thread here, a separate thread, a task that we're going to build that will print out a message every time a message comes in on the data input stream. Okay? So we need to build another task. And let's call this the client receive task. And the client receive task, all it's going to need is the data input stream that it should be monitoring. Okay. Okay. And so now every time there's a message on this data input stream, it's just going to print it out. So we could have this be a while true. I don't particularly like that, though. Let's add some controls to this so that we're not introducing an infinite loop on our client system here. This can introduce what we call a runaway thread, which is we're creating a thread with an endless loop in it. And so that way, even if we try to terminate our program through normal means, we could end up having a thread hanging out there. So what I'm going to do here is I'm going to introduce a separate variable, keep going, which we will give it the default value of true. Okay, so this still, right now, this still looks like an endless loop because keep going is true. But I'm going to introduce a public method here called stop, which will set keep going equal to false. Okay, so whenever the stop method is called on this task, it'll terminate this loop, all right, which is going to be important. Okay, but otherwise, as long as this task is still going, it's just going to print out any string data that it reads from that data input stream. Now, this, of course, could cause a try-catch, or it could cause an exception which we need to deal with the try-catch. All right. Very simple task. All it's doing is it's looping around, grabbing input from this data input stream and printing it out. So what this means is when we run this task on our client program will not need to worry about checking to see if anyone typed anything in the server, it's just going to print it out automatically. Okay. So we can, up here at the top, when we open up this data input stream, we can start this task off. Let me put it on space down here. All right. CRT, new client receive task. All right, we give it the data input stream that we want it to monitor. And unlike on the server side, we're only worrying about this single thread. So I'm just going to create the thread object and start it. I'm not even going to use an executor service. I'm not even going to store this in a variable. I'm just going to create the thread and tell it to go. And it'll basically run on its own throughout the entire program. And then down here at the bottom, before we close the socket, I'm going to call that stop method that's going to terminate this otherwise endless loop here inside of the client receive task. Okay. Now, this frees us up to get rid of any other places in this main method where we are checking the data input stream for a string. Okay. And so we can pull that out. We can pull that out because that task is going to take care of that for us. We no longer have to separately monitor the data input stream. Okay. All right. So now I'm going to run this again. We should see some chat action. So I've started up the server. Of course, that has to come first. Have Zach join. Run another client. Have Amanda join. Come back to Zach, and Zach can now see that Amanda has successfully connected to the server. And Amanda can say hi. And we come back to Zach's display, and Zach can see that Amanda has said hi, and so Zach says hello back. And Amanda can see that message. Let's throw another client in the mix. James has connected to the server. They both see that message. And we get a what's up from James. And it's replicated all across. So we've got the beginnings of a chat room here. Now, again, this is a bit more complicated than what's actually required for the project, so don't dig too deep into it. I am going to upload all of this code as well as the code from the previous video. So feel free to dig through, and as usual, you can direct your questions to the questions and answer discussion board. Thanks for watching.